Good evening, children. Good evening.
Good evening.
Good evening.
Good evening, children.
Good evening, ma'am.
Good evening. All right, we'll continue with heights and distances, or what is called some applications of trigonometry in NCERT. Yeah. This will be the first question for today's class. A boy whose eye level is 1.3 meters from the ground. A boy whose eye level is 1.3 meters from the ground. So this is the ground level. This is the ground level. And the boy is 1.3 meters tall. Okay. So the boy is 1.3 meters tall. This is the ground level. This is the ground level. A boy whose eye level is 1.3 meters from the ground. So this is the horizontal. This is the horizontal drawn through the eye of the observer. This is the horizontal drawn through the eye of the observer. The height of the observer is 1.3 meters. Spots a balloon moving with the wind. He spots a balloon moving with the wind in a horizontal line, which means the balloon is maintaining the same vertical height from the ground. It's moving in a horizontal line. So like this, it's moving like this in a horizontal line. It's moving like this in a horizontal line, maintaining the same vertical height from the ground. Maintaining the same vertical height from the ground. All right. This is not the figure, like I'm just trying to show you the information in the question. We'll do the figure. So moving with the wind in a horizontal line. So this is the horizontal line in which the balloon is moving, and it's maintaining the same vertical height from the ground. Okay, so at some height from the ground, the angle of elevation of the balloon from the eyes of the boy, the angle of elevation of the balloon from the eyes of the boy at an instant is 60 degrees. Okay. After 2 seconds, the angle of elevation reduces to 30 degrees. So when the angle of elevation reduces, that means the balloon is flying away from the eye of the observer. Because when it's, see, if the balloon is coming towards the boy, then he has to raise, he has to look higher to look at the balloon. He has to raise his head and look higher up to look at the balloon, in which case the elevation will increase. If the balloon were moving towards the boy, then the boy has to look still higher up to look at the balloon, which means the angle will increase. See, imagine you are at a foot of, you're standing at the foot of a tower or somewhere, okay, not exactly the foot of the tower, this is the tower, and say you're here. Okay, to look at the top of the tower, say the angle of elevation is 60 degrees. Now, if you move closer to the tower, you have to still, it's meaning you have to take more effort to look at the top. You'll have to raise your head still higher. So the elevation will increase. When you move towards the tower, the elevation will increase. But when you're going away from the tower, you can look at the top of the tower more easily. When you move away from the foot of the tower, you can look at the top of the tower more easily, more conveniently, without, raising your head too much. So the elevation reduces. So if you're closer to the object, the elevation is more. If you're far away from the object, the elevation is less. The elevation of the top will be less. So here, after 2 seconds, the angle of elevation reduces to 30. That means he's able to see the balloon more easily. Now, what you'll have to note here, I don't want anybody walking in the class, please listen to me. So what we need to understand here is the boy does not change his position. It's the balloon which takes a new position. We have one initial position and one final position for the balloon. But the boy is at the same place. he looks at the balloon at two different positions from the same place. He does not change his position. In some cases, the object is fixed. The observer takes two new positions. In some cases, the object is fixed. The observer, he looks at the top and the elevation is given, and then he moves closer, or he goes far away from the object, and again he looks. So in this case, the observer takes two different positions, but the object is fixed at one position. So it can be that the object is fixed and the observer is taking two positions, or the observer is at one position and the object has one initial and final position, or one original and new position. Okay, so after 2 seconds, the elevation reduces to 30, which means the balloon is going away from the observer. That's why he's able to see it more easily now. The elevation is small, which means the balloon is moving away from him. If the speed of the wind is 29√3 meters per second, then find the height of the balloon from the ground. Now this speed, see here, speed and time cannot be used in the figure. Speed and time, I hope all of you are listening. Speed and time cannot be used to mark in the figure. See now 2 seconds, you cannot mark like this one is 2 seconds. You cannot mark time in the figure. At this, in the same way, you cannot mark speed in the figure. So using the speed and time, you must find distance, which can be marked in the figure. You cannot mark 29√3. You cannot say that, okay, this is 29√3. No, that's speed. Speed is not represented by a line segment. 2 seconds is time, which cannot be represented by a line segment. A line segment is used to represent distance. So what do we do with the speed and time? It cannot be represented in the diagram. Then how do we make use of this information to show it in the diagram? Using speed and time, you will have to find the distance, and the distance you'll have to mark it in the diagram appropriately. So see children, the question is, now we don't have to read the question at all. See here, I'm taking a different, there's a different question. There's a different question. Now we read and we have the question in our mind. So now see here, this is the ground level. This is a different question. This is question number 21. This is a different question. Now see, we're doing the diagram for the for question number 21. See here, this is the ground level. Okay, boy, 1.3 meters tall. This is the horizontal through the eye of the observer, and complete that rectangle. Okay, this also will be 1.3. So this is the eye of the observer. Complete that rectangle, you know. So opposite sides are equal, so 1.3. Now take two positions for the balloon. So this is the original position of the balloon, and this is its vertical height from the ground. From the ground, so till here. Okay, this is the new position of the balloon because it's going away from the eye of the observer. So this is the new position of the balloon. Okay, and this is its vertical height from the ground. Excuse me, it's not straight, but I'm not correcting it. Okay, and this is the same horizontal distance. In the same horizontal line, sorry, not horizontal distance. It's moving in the same horizontal line. So we got it. Now 1.3 meters tall, ground level is different from the horizontal. The horizontal is the line drawn through the eye of the observer. Okay, so this is the horizontal. This is the horizontal. This is, you don't have to write this, but I'm just telling you, this is the horizontal, this is the ground level. This is the ground level. This is the boy, this is the eye of the observer, balloon at two different positions. Now, the elevation was first 60 degrees. So where do you mark the elevation? Horizontal line of sight, angle of elevation. It's the angle between the horizontal and the line of sight. This is the horizontal. And which is the line of sight? He's looking somewhere here, children, but I'll take it here. He's looking somewhere here, but we'll not mark it there. We'll just take it like this. Because everything is a fine dot. Balloon you cannot draw like this. This is the balloon, that's all. We're just showing the circle for us to understand. But everything is just a dot here. This is the position of the balloon. Okay. Okay. So this is the horizontal and this is the line of sight. This is the line of sight. Line of sight. So the angle between the horizontal and the line of sight is the angle of elevation, which is initially 60 degrees. Now, since the elevation is 30 degrees, since the elevation reduces to 30 degrees, we understand that the balloon is moving away from the eye of the observer. So now this is the new line of sight. This is the balloon, position of the balloon. This is the eye of the observer, which is the line of sight. The line connecting the eye of the observer and the object observed. The line or the line segment connecting the eye of the observer and the object observed. So this is the eye of the observer. This is the object observed. The line segment connecting these 2 points is the line of sight. So this is the new line of sight. This is the new line of sight. And which is the horizontal line of sight, horizontal. You can see the horizontal here. So this angle is 30 degrees. This one is 30 degrees. This one is 30 degrees. This full thing is 60. This is 30 degrees. Now, this distance, that is the balloon was here and it's taking this new position here. This distance is covered in 2 seconds. This distance is covered in 2 seconds at the rate of 29√3 meters per second. This distance from here to here, this distance from here to here is covered in 2 seconds by the balloon at the rate of 29√3 meters per second. So speed by time, distance is equal to speed into time. Distance is equal to speed into time. So 29√3 into 2, 58√3 is the distance. So this distance is 58√3 because this distance is covered in 2 seconds at this speed. So this distance in the air is 58√3. Correspondingly, come below, it's a rectangle. So this one is 58√3 meters. This one is 58√3 meters. Because this distance is covered in 2 seconds. So the distance covered in 2 seconds is 58√3 meters. Which means this line segment is 58√3 meters. Now with this given to us, we need to find the height of the balloon. So we need to just find this one plus 1.3 will give us the height of the balloon from the ground, or the vertical height of the balloon from the ground. How many of you were listening to me? Raise your hand. How many of you started working and got the answer or trying to get the answer? How many of you were really listening to me? You don't have to make me happy. Shreyas and Ram, Rajarajeshwari, Kanishka, Priyanka, Hitesh. So Ananya, oh. So Ananya. Yes, Ananya?
No, this is Priyanka. I joined late because I had a network issue today.
So sorry, it's not very clear, so I couldn't follow what you're trying to say. Ananya, why you were not listening? You already know it, so you started working, is it?
No, my dog was troubling me for playing, so I had to go look after him for some time.
Okay, fine. I don't know what I should answer for this. So, all
Sorry.
right, fine.
Am I clear now?
All right, thank you, children. I hope that was a genuine response. Yeah, because sometimes when we learn it in school, we don't want to listen, but maybe you're getting something new. Your teacher would have tried her best to, make everything easy for you, but still, maybe something new I had to tell you. Maybe from what I said, something was new to you, and that is useful. So, which is why I always want you to listen. It's okay even if you know it already, you can still listen to me and judge how good or bad I am. So this is the figure, children. Is it understood? Any doubt in making the figure? Any doubt with respect to making the figure?
No, ma'am.
Say yes or no.
Yes, ma'am.
No doubt?
Yes, ma'am.
Yes, meaning you have a doubt or no doubt?
Ma'am, no doubt, ma'am.
All right, yeah. All right, children. So now, see, it's very simple. Now we got everything. I told you speed and time cannot be represented in the figure. So you have to find the relevant distance. Distance is equal to speed into time. And this is GH is equal to 58√3 meters, which means CE is equal to 58√3 meters. Yeah. Yeah, take the question. Write on the question first. You need to read the question, 2-3 times, understand the question. That's how you practice for the exam. Read the question, understand the question very, very clearly. Here, the ground level is different from the horizontal line through the eye of the observer. If the height of the boy were not given, then the ground level and the horizontal will be the same. The boy doesn't change his position. It is the balloon which has one original and new position, which is covered in 2 seconds. Done writing the question? Done writing the question, children?
Yes, no.
All right. So this is the solution. Because you'll have to draw the figure first. And in right triangle, okay, we'll have to first find the distance. Speed is equal to so this is what I do, So I'll not mark H, X, Y and all that as soon as I draw the figure. As and when needed, I'll go back to the figure and mark. So now I wrote tan 60 is equal to CG by AC. So I don't want to continue with CG and AC. So I go back to CG and I call it H because it's the height of the balloon. And oh no, 1 minute. This balloon is H. This balloon is H. CG alone is H. CG alone is H. This one is the total height is H plus 1.3. Okay, let me make it clear here. Let CG is equal to EH be equal to H. and let AC be equal to X. Yeah, not the total thing, only that GC is H. So now when I want, I'll go back to the figure and mark this. Now in this equation, H, X both are unknown. So nothing can be done. So maybe you'll just cross multiply and you'll write H is equal to root 3x because you don't know what to do. You can even leave it like this. So just mark this equation 1 and leave it here. I'll just get my phone, children. Okay, which is the other right triangle? AEH. In right triangle AEH. In right triangle AEH. Tan 30 degrees is equal to EH by AE. Tan 30 EH AE. Tan 30 degrees is equal to EH by AE. Tan 30 is 1 by root 3. EH is the same as the earlier line segment GC, which is H, by AE. AE is X plus 58 root 3. AE is AC plus CE. AC plus CE. So 1 by root 3 is equal to H by AC is X. I'll just see again. Plus 58 root 3. Plus 58 root 3. Now cross multiply, you get, you can, now what's the question, children? You have to find the value of what? H. Because you'll have to find the height of the balloon from the ground. So that means you want to have H in the equation. You don't want X. See, you can substitute anything, children, but if you want to do it like directly get the answer, you have to find H. That means you don't want to remove H from the equation. You want to remove X from the equation. Because you have to find the value of H, right? So let H be there. You don't want X. Now what is X from here? X is equal to H by root 3. So you can do that. Now come back here. Now you can come back here and write X is equal to, H by root 3 and call it 1. Because here in place of X, you're going to write, in place of X, you're going to write H by root 3. So what will happen in place of X when you write H by root 3? In this equation, there is only H. So you can work it and find the value of H and hence find the height of the balloon. You can even cross multiply and then substitute. When you cross multiply, you get X plus 58 root 3 is equal to H root 3. Now substituting X is equal to H by root 3 plus 58 root 3 is equal to H root 3. Okay, this is using 1. Let me write using 1. All right, then since you're finding the value of H, collect all the H terms on one side. Since you're finding the value of H, collect the H terms on one side. So see this 58 root 3, if it goes to the other side, it becomes minus 58 root 3. Don't get scared. Then the minus and minus will get cancelled. Or if you don't want it to become negative, you can have it on this side. 58 root 3 like this. 58 root 3, you can have it like this, is equal to H root 3 minus H by root 3. Anyways, you can transpose. I'm saying if you don't want it to become negative, you can have it on the same side. 58 root 3 is equal to H root 3 minus H by root 3. Collect all the H terms on one side. So you have 58 root 3 is equal to Root 3 is the common denominator. Root 3 is the common denominator. So you will get 3h minus h. Now again on cross multiplying, you get 58 into 3. 58 into 3. Because root 3 into root 3 is 3. 2 carry over 174. So 174 is equal to 2h. So h is equal to 174 by 2, which is equal to 87. Therefore, GD is equal to h plus 1.3, which is equal to 87 plus 1.3, which is equal to 88.3. Therefore, the vertical height of the balloon from the ground is equal to 88.3 meters. Write down, children. Done the first slide, children? Finished working? All of you? Very feeble it is.
Okay, ma'am, I'll try to see if I can.
It's very feeble. I can barely understand. Yeah, Ram, Rajeshwari, Kanishka finished working. Priyanka, Ritesh.
Yes, ma'am.
All right.
Yes.
All right, children. Let's go to the next one. Any question here? No? Yeah, look at this one. A 1.5 meter tall boy is standing at some distance from a 30-meter tall building. Again, here the height of the boy is given to you. So the horizontal is different from the ground level. The horizontal is a line drawn through the eye of the observer. The horizontal is the line drawn through the eye of the observer. And since if the height of the observer is not given, then the ground level is treated as a horizontal. Now here the height of the boy is given. So the ground level is different from the horizontal. Ground level, 1.5 meter tall boy, tall building. So 1.5 meters tall boy. This is the building. This is the building. A 1.5 meter tall boy is standing at some distance from a 30-meter tall building. This is a 30-meter tall building. Complete the rectangle. Complete this rectangle. So you know that this is also 1.5. But the height of the building is 30. So the remaining part, this one will be 28.5. This will be 28.5. So see, we did not read the question fully, but as much as possible, we'll try to make a rough sketch like this. This full thing is 30. This full thing is 30. It's a 30-meter tall building. So from the top of the building to the foot of the building, it is 30 meters. The foot will obviously be on the ground. The foot of the building is obviously on the ground. So from the top to the foot, which is on the ground, the height is 30 meters. But the height of the boy is 1.5. So the rest of the height is 28.5. This is about the tall building. The boy is 1.5 meters tall. So this is the horizontal through the eye of the observer. And this is the ground level. This is the ground level. This is the horizontal, which is drawn through the eye of the observer. The angle of elevation from his eye, the angle of elevation from his eyes to the top of the building increases from 30 to 60 as he walks towards the building. So here the observer takes two positions. The building cannot move. The building is there wherever it is. The boy moves towards the building. It's given. He moves towards the building. So the boy is now here. The boy is now here, where you can see 1.5, and then he moves closer to the building. Okay. He then moves closer to the building like this. So this is the position of the boy. This is the new position of the boy. This is the original position of the boy. Original position of the boy, new position. He is moving towards the building. And you can see that the elevation increases because he has to still look higher to look at the top of the building. Find the distance he walked towards the building. So what you have to understand here is that the building is wherever it is. The boy takes two positions, one original, one new position. From the original position, he looks at the top. From the new position, he looks at the top. So two different angles of elevation. 30, 60, he's moving closer to the building. That's why the elevation is increasing. He has to raise his head still higher to look at the top of the building. Now the lines of sight. Okay, so this is the top of the building. And this is the line of sight connecting the eye of the observer and the object observed or the position observed. Again, this is the line of sight because this is the new position of the boy. This is the top of the tower. Line of sight connecting his eye and the object or the position observed. So this is the horizontal. This is the horizontal. This is the line of sight. This is the angle of elevation. Again, this is the horizontal. This is the line of sight. This is the angle of elevation. It was first 30 degrees. Now it is 60 degrees. Find the distance he walked towards the building. So you need to find this distance. This distance you should find. This distance he walked towards the building. Now the total height of the building is given 30 meters. And I said complete the rectangle. Whenever the horizontal and the ground level, they are different, complete that box, complete that rectangle. So if this is 1.5, the opposite side also will be 1.5. The total height is 30. So 30 minus 1.5, the rest of it is 28.5. Now let me mark. Tell me which triangle I'll have to take first. A, B, C, D, E, F, G. Yeah. Which triangle will you take first?
Triangle ABD, ma'am.
ABD. Why? Because you know
We can
one
find
angle.
BD.
You can find BD with that. Very good. Very good. So in triangle, in right triangle, ABD, tan 60 degrees is equal to opposite. Opposite is only AB by adjacent BD. Tan 30 is √3. AB is 28.5 by BD. You can call it X. If you want, you can call it X. Or you can have it BD itself. All that is left to you. I'm marking that as X. I'm taking this as X. Let BD be X. Okay, by X. Now you cannot leave it like this. You have to find the value of X. You can find the value of X. In this equation, there is only one unknown X. In this equation, there is only one unknown X. So solve and find it. Don't leave it like this. When in the equation, you have two unknowns, H and X. Then you leave it like that because you cannot find the value of anything. Here you'll have to solve and find. So on cross multiplying, rationalize. Now take the other triangle. ABF. ABF. Now take the other triangle and you can find the value of y straight away. All right, I hope this is done. Now in right triangle, ABF, tan 30 degrees is equal to opposite AB by BF. AB by BF, tan 30 is 1 by √3, AB is 28.5, BF is X plus Y. So 1 by √3, or you can cross multiply at this point. So on cross multiplying, X plus Y is equal to 28.5 √3. We already found the value of X, which is 9.5 √3. So 9.5 √3 plus Y is equal to 28.5 √3. Y is equal to 28.5 √3 minus 9.5 √3. So Y is equal to 19, √3, if I'm not wrong. Y is equal to 19 into 1.732. Is it given? Okay. Y is equal to whatever? 19 into 1.732. 32.908. 32.908 meters. So this is the distance he walked towards the building. Is the slide over, children?
Yes, ma'am.
Okay. So the distance he walked towards the building is 32.908 meters. Yeah, this is a test. The 32nd question is a test. Do it. 32 is a test. Or if you take down the question and try it. Got the answer, children? Lower your hands, class. Yeah, children, please tell me if you got the answer or are you still working on it?
I'm working now.
Okay, thank you, Tarun, for answering. Thank you. Okay. Next class on Thursday, we'll be doing some important questions on circles. Circles, the chapter circles. I'll do the extra problems first and then NCERT.
Ma'am, on Thursday, will it be a physical class or online class, ma'am?
Depends on the weather conditions. It will be physical only always. But if the weather condition is bad, then I don't want, because there are people coming from a little distance. So if people don't come, then again, it becomes a problem, no? I go to the center and the first class, only 4 of them turned up. Or maybe I'll take a poll. If the weather is with raining, no, I'll just take a poll. Okay, let me ask you all now. So even if it's raining, is it that you'll be coming by auto or car and you don't mind coming? How many of you will be joining the physical session Thursday? Now leave the weather condition. Otherwise, Kanishka, Priyanka, Tarun, Ram, Nandini, Hitesh. Okay, now, so, okay, 6 of you. Fine, now my question to you, the 6 of you is that for me, it's fine, like irrespective of the weather conditions, I can make it as a center. I have, no issues with that. I should not have any issues with that. Okay. So I'm always, for the physical classes. But today I just changed because I was like scared if people don't turn up because it's raining, and supposing 1 or 2 of you come to the center and, the rest are online. So I didn't want that to happen. So I thought, okay, let me make it online only today. Now the 6 of you tell me, irrespective of the weather conditions, will you always make it to the physical class?
Yes.
Meaning you'll be traveling by auto or car, so it doesn't mind if it's raining. Is it like that? Hitesh, Nandini.
Yes,
Now
ma'am.
lower your hands, the 6 of you lower your hands and raise your hand to say that irrespective of the weather conditions, we can make it to the class. Yeah, lower your hands first. Yeah, now raise your hand, irrespective of the weather condition, I can make it to the class. Kanishka, Priyanka. What about Hitesh? Nandini?
Ma'am, my dad will actually drop me by bike, ma'am, so it will not be possible when it is raining, ma'am.
Ram can come, is it? Tarun also. You're
Yes.
sure, Tarun? Tarun and Ram?
Yes, ma'am.
Okay.
Yes, ma'am.
Hitesh?
Ma'am, I too will be coming with bike, so I'm not sure with that.
You're not sure. Maybe on these days you have to book an Ola or something like that. Because Hitesh, you always wanted physical classes, right?
Yes, ma'am.
Okay, fine. The 4 of you, you're sure, right? So then I'll make it physical. Shall I do that? The 4 of you will definitely turn up, right?
Yes,
Yes,
ma'am.
ma'am.
Yes.
All right, fine. Okay, then it will be physical. Yeah, fine. Let's continue.
Ma'am,
Yeah.
I got the answer, but I don't know whether it is right or wrong.
Oh, even I don't have the answer with me. I have to work and check. What's your answer, anyways?
It's 30 root 2.
30 root 3, huh?
Root 2, ma'am.
30 root 2. Okay. All right. The figure will be something like this. A boy is standing on a horizontal plane. Okay, a boy is standing on a horizontal plane. A boy is standing on a horizontal plane. So the height of the boy is not given. That's it. So he's standing here. From here, the elevation is measured. A boy standing on a horizontal plane finds a bird flying. Shreyas, can you take a picture of your answer and share it on WhatsApp with me?
Yes, ma'am.
Yeah, do it right away. Yeah.
Ma'am, I too got the answer.
Yeah, what's your answer?
42.3 meter.
Before that, it is 30 root 2, is it?
I'm also got the answer.
Yes, ma'am.
Ma'am, I've just shared the picture.
Yeah, I got it from Shreyas. Good. Tarun and Raja Rajeshwari also can share your pictures.
Okay, ma'am.
Yeah. All right. So class, a boy standing on a horizontal plane finds a bird flying at a distance of 100 meters from him at an elevation of 30 degrees. So see here, this is the ground level, horizontal plane. All right, the ground level. Now, okay, let me not say the ground level. This is the horizontal plane. Maybe he's standing on the terrace, so who knows? He's on a horizontal plane. So this is the horizontal, sorry. So this is the horizontal plane. And say this is the position of the observer, the boy. He finds a bird flying at a distance of 100 meters from him. So say this is the bird in the sky. The distance between the boy and the bird is 100 meters. See, in maths, when we say distance, it's always the straight line connecting the 2 points. One end is the bird, the other end is the boy. The line segment connecting these 2 points is the distance between the boy and the bird. The distance between the boy and the bird is a straight line connecting these 2 points. Horizontal plane, boy, bird. This is the distance between the bird and the boy. That straight line segment connecting the boy and the bird is the distance between the bird and the boy, which is 100 meters. And the elevation is given to be 30 degrees. This is the horizontal. And of course, the distance is the line of sight. This itself is the line of sight. This itself is the line of sight. So the elevation is 30 degrees. A girl standing on the roof of a 20-meter high building It's later given that they are on the opposite sides of the bird. So the bird is here. The girl and the boy, they are on the opposite sides of the bird. Later in the question, it's given, see here, the boy and the girl are on opposite sides of the bird. So the girl is not on the horizontal plane. She's standing at a height of 20 meters from this horizontal line. So 20 meters. This is the vertical height of the bird from the horizontal plane. This is the height of the bird from the plane. Okay, and complete this rectangle. This is also 20 meters. This is also 20 meters. What is this 20 meters? This is the position of the girl. The girl and the boy. This is the boy. The boy and the girl are standing on opposite sides of the bird. This is the bird. They're on opposite sides. The boy is here. The girl is standing 20 meters higher than the boy. And the elevation for the girl is 45 degrees. It's 45 degrees. For the girl, it's 45 degrees. Find the distance between the bird and the girl. This is the bird, this is the girl. So you need to find this one. This you have to find. I call it A, B, C, D, E, F. Nandini, which triangle to take first? Kanishka, which triangle first?
ABC, ma'am.
ABC. Yeah, in ABC, 30 degrees, 100. What would you like to find? BC or AB?
AB, ma'am.
AB. AB minus 20 is what? Will give you what? AD. AD. Now you will take which triangle?
After finding AD, ADE, ma'am.
ADE. And you will find?
AE, ma'am.
AE. Very good. AE. And you'll have to use relevant ratios. Very good. Yeah. So first in right triangle, ABC, ABC, you need to find AB. So how will you connect AB and 100? It's sine 30. Sine 30 degrees is equal to opposite AB by hypotenuse AC. So sine 30. What is the value of sine 30? 1 by 2 is equal to AB by AC 100. So AB is equal to 50 meters. Now you know that AD plus DB, the AB is nothing, AB is 50. So AD will be 50 minus 20, 30 meters. Now in right triangle, ADE, you need to find AE, the hypotenuse AE. And you know AD. So again, sine 45 is equal to opposite AD by hypotenuse AE. 1 by root 2 is equal to AD 30 by AE. So on cross multiplying, you get AE is equal to 30 root 2 or 30 into 1.41. What is it, children? What's 30 into 1.41?
42.3
42.3.
Didn't get it clearly. Okay. 3, 1, 2,
3.
1, 3. 42.3, yeah?
Yes, ma'am.
Yeah. So the distance between the bird and the girl is 42.3 meters. Right now, Malfi?
Ma'am,
Yeah.
ma'am, is it necessary to take root 2 as 1.414 and then convert it?
No, it's given in the question to, if the value of root 2 was not given, then you will have to take 1.414. But in the question it's given, no, root 2, take root 2 is equal to 1.41. You just have to take that.
Okay.
Yeah. All right. Yeah. The angles of elevation of the top, it's off. Was a mistake while typing. It's OF off. The angles of elevation of the top of a tower from 2 points on the ground at distances A meters and B meters from the base of the tower and in the same straight line are complementary. Prove that the height of the tower is root 2 AB meters. If nothing is mentioned, we assume that the 2 points are on the same side of the tower. If they're on the opposite sides, it will be given. If they're on the opposite sides, it will be given. If the 2 points are on the opposite sides, it should be given to you. If nothing is mentioned, the assumption is they are on the same side. The 2 points are on the same side. Okay. The angles of elevation of the top of a tower, all right, from 2 points on the ground. From 2 points on the ground at distances A meters and B meters from the base of the tower. And the points are in the same straight line. These 3 points, that is the foot of the tower, and the 2 points. They are the same straight line. Okay. And the angles of elevation are complementary. The angles of elevation, they are complementary. So let's try to make the diagram. See here, ground level, tower, say 1 point, the other point. This is the foot of the tower. This is the foot of the tower. This is the top of the tower. This is the tower. This is, say, any point. We don't know which point is first and which is second. So 1 point here, 1 point here. Okay. From these 2 points, they look at the top of the tower. So this is the line of sight. And this is the other line of sight. Sorry, please understand. That's the other line of sight. That's the other line of sight. Now the distance A and B. This is the foot of the tower. This is 1 point. The distance is A. This is the foot of the tower. This is the other point. The distance is B. The distance between what? The distance between the foot of the tower and 1 point is A. The distance between the foot of the tower and the other point is B. The distance between the foot of the tower and 1 point is A. The distance between the foot of the tower and the other point is B. So see here, this is the foot of the tower. This is 1 point. Between that, the distance is A. Again, foot of the tower, this is the other point. The distance between those 2 points is B. This is not B. What is this? This is the distance between the 2 points. That is not given. That we can find now, but that's not given. This one is the distance between the 2 points. That is not given. Okay. Now the angles of elevation are complementary. So that means if you take this as theta, this will be 90 minus theta. Or you can take this one as theta, anything. You can take this as theta. You can take any angle. One angle is theta, the other one will be 90 minus theta. If this is theta, this is 90 minus theta. Anyway, you can take it. A, B also, you can exchange A and B. You can take this as A. You can take this as A and this as B. All that will not affect the answer. Anyways, you can take it. So this is the figure. You can see the tower, the top and foot of the tower, 2 points on the same side of the tower. The 2 points and the foot of the tower, they are in the same straight line. These are the 2 points and this is the foot of the tower. They are in the same straight line. You can see they're in the same straight line. Angles of elevation. So take the lines of sight. The angles of elevation are complementary. So theta and 90 minus theta. A and B. Distance between the foot and one point, foot and other point, A, B. Now, yeah, you can understand this yourself, children. Maybe you already know it. Even if you're seeing this for the first time, it is self-explanatory. You can understand it. Done, children?
Yes, ma'am.
All right. So from the two triangles, we find tan theta and tan 90 minus theta. You know that tan 90 minus theta is cot theta. So on multiplying the two equations, we get the required result. Yeah, do this. Got it, children? Please answer.
Yes, ma'am.
Finished? You got the answer?
Yes, ma'am.
All right. Yeah, this is the next question. Yeah, this is the next question, children. Yeah, somebody's mic is enabled. Please disable your mic. Nandini, please disable your mic. Yeah, what's the height of the tree? What's the height of the tree, children? Ananya, are you working?
Yes, I'm working. I just completed the question for this. I'm going to start the answers.
Ma'am,
Yeah, Shreyas?
is it 3 √3 meters?
3 √3, yeah?
Yes, ma'am.
Okay, let's see.
Ma'am,
Yeah?
ma'am, I got 9/√3, ma'am.
Yeah, that's what on rasterizing you'll get 3 √3. 9/√3 is 3 √3.
Okay, ma'am.
Yeah.
The final answer I got it as 15.588.
15.588. Okay. So that is different from 3√3. Let me see. My calculator is not working. So what is 9 into 1.732? This is the answer, children. It's not 3√3. Trace and Nandini, both of you are wrong. Ananya, 15.588. Yeah. So the height of the tree is AC, children. The height of the tree is AC. The broken part is AB, which falls on the ground as BD, making an angle of 30 degrees with the ground. Look at the figure. Look at my figure on the screen. AC is the tree, the height of the tree. The tree breaks at the point B. So the broken portion is AB, which falls on the ground, making an inclination of 30 degrees with the ground. So AB falls on the ground as BD. AB is BD. It breaks and it falls, touching the ground at an angle of 30 degrees. So AB is BD. The part of the tree that is still intact with the ground is BC. The part of the tree that is still on the ground is BC. BC. And AB is what is BD. So the height of the tree is X plus Y. The part that is still intact with the ground, BC, plus the broken part, BD. BC plus BD is the height of the tree. X plus Y is the height of the tree. Work this, children. I'm sure you found your mistake. If you still have a question, you can ask me. Yeah, Ananya, you're right. But the figure could have been more, like informative. So you're like, I think you're trying to say that if the broken part has fallen on the ground, then this part will not be there, but you can still show it.
Okay.
Yeah, Shreys and Nandini, is it fine?
Yes, ma'am, I got it.
Yeah. What about Shreys and the others? Tarun, Hitesh, Raja, Rajeshwari, Kanishka, Priyanka, Ram.
Yes, ma'am. I got.
Sashmin. Done, children? Can we go to the next one?
Yes, ma'am.
Yes.
Yeah. Yeah. This is the next one. Got the answer?
I'm 17.32 meters and 40 meters.
Okay, let's check. Yeah.
Ma'am, I too got the same. Ma'am, the height is 40 meters and the distance between the hill and the ship is 30 by root 3 meters. Ma'am.
All right, good. One second. If you want, you can even mark this as 30 degrees. Angle of depression is equal to angle of elevation. You can even take this triangle. You can even take this triangle, this one, this triangle. You can mark 30 degrees here and take this triangle, like BDF. BDF, you can mark. You can mark 30 degrees here because the angle of elevation is equal. Alternate angles are equal. You can mark 30 here and take the triangle BFD also. BFD. So I'm taking BCD itself. So tan 30 degrees is equal to opposite 10 by adjacent y. So tan 30 is 1 by root 3. Y is equal to 10 root 3. So y is 10 root 3. If you substitute, so the height of the hill, the distance of the hill from the ship, hill and ship is y. Yeah, I think Nandini and Ananya shared your answers. You're right. 10 root 3 and 10 root 3 or 17.32 and 40 meters. Done, children?
Yes, ma'am.
Yeah. Yeah, do this one, children. Done this one, children? Done writing this, children?
Yes, ma'am.
Okay.
Yes, ma'am.
All right. I just want you to finish this one. We'll understand this in the class tomorrow. Yes, children, I want you to do this, but this will wind up the session for today. I'll explain these two in the class tomorrow. All right, children, since it's time, take a screenshot of this answer and finish it in your classwork. The last one and this one, in tomorrow's class, when we start tomorrow's class, we'll understand these two and then start the revision program on quadratic equations. Take a picture, children. All right, children. So that's it for today's session. Thank you so much. Good night.
Thank you, ma'am.
Thank you.
Thank you.
Thank you, ma'am.
Thank you. Thank
Thank
you. Good
you.
night. Thank you, children. Good night.
Thank you, ma'am.